Hello everyone, my name is Jenai Adderley and my topic for this video lecture is ecological productivity in upwelling areas and the effects of El Nino. I hope that you enjoyed this video and hopefully learned something from it as well. While this is a broad topic, I will focus on a few key features. These include the definition of upwelling, the characteristics of an upwelling area, and ecological productivity. I will also focus on the El Nino event and its effects on the Peruvian coastal upwelling system. First, let's start by defining upwelling. This is the process by which wind currents blow parallel to the coastline and force surface waters offshore. The cold, deep water rises in order to replace the warm surface water that was blown away. Here is a diagram that illustrates the process of upwelling. You can see the surface water being pushed away and the deeper, colder, nutrient-rich water rising from below to replace it. Now, we move on to the characteristics of an upwelling area. The first characteristic of an upwelling area is cold surface waters. The cold waters that are usually found at greater depths have now risen due to the removal of the warmer, less dense water. The second characteristic is high nutrient levels. Nutrients accumulate in deep water because no light reaches for photosynthesis to occur and rise with the deep waters. The third characteristic is high productivity levels. Due to the accumulation of nutrients, photosynthesis can now take place now that the nutrients have been brought to the surface. So now, we're going to be moving on to another key aspect, which is ecological productivity. Ecological productivity can be defined as the rate at which energy is fixed by an organism, community, or ecosystem. In this case, the ecosystem would be the upwelling area. Primary productivity can be expressed in two ways. The first is by the GPP, or the gross primary production. The second is by the net primary production, or the NPP. The gross primary production is the total amount of solar energy fixed by autotrophs. The net primary production is the GPP minus the respiration by autotrophs, or simply the carbon that remains after respiration. Light is attenuated or diminished in water, and as a result, photosynthesis is only able to occur in shallow waters. This means that the primary production is greater at the surface level than at deeper depths. The productivity increases at surface level due to the rise of cold, nutrient-filled waters. As a result, the increase in nutrients promotes growth in the euphotic or sunlight zone. The high rate of ecological productivity in upwelling areas usually makes them good fishing grounds. As we continue, we move on to the phenomenon of El Nino and its effect on upwelling systems. But before we get to the El Nino event, we must first begin by talking a little bit about a particular ecosystem that is affected by it. Many ecosystems are affected by the El Nino event. One such ecosystem that relates to this is the Peruvian coastal upwelling system. This upwelling area ranges from 4 degrees south and 40 degrees south along the western coast of South America. This upwelling area consists of high productivity levels due to the sustenance provided by the winds constantly during the year. Fishing is considered one of the primary industries of Peru, and because of these favorable conditions, the Peruvian coastal upwelling system is very vital to the economy of the country. So many of you may be wondering, what exactly is El Nino? Well, this is actually short for El Nino Southern Oscillation, and the phrase El Nino refers to the warm oceanic effects of El Nino Southern Oscillation, while La Niña refers to the cool oceanic effects. It occurs simultaneously with Southern Oscillation, which is the change in atmospheric pressure. This can be described as a weather phenomenon that occurs between 2 to 7 year intervals in the Pacific Ocean. During this time, the sea surface temperatures and rainfall are remarkably high, and the east to west trade winds are weakened. In order for El Niño to occur, the temperature in the equatorial Pacific Ocean must increase by 0.5 degrees Celsius for 3 successive months, and it must be accompanied by a change in atmospheric conditions and rainfall patterns. During an El Niño event, the warm waters that would usually move westward now move eastward, which causes moisture to rise into the air. The change in the direction of the currents causes a buildup of warm surface waters off the Peruvian coast. As a result of El Niño, there are adverse effects to the Peruvian coastal upwelling system. The thick layers of warm surface waters prevent the cold, nutrient-rich waters from rising, thus preventing the upwelling process from occurring and decreases the overall ecological productivity of the ecosystem. If the nutrient-rich waters cannot rise to the surface levels, photosynthesis cannot occur, and marine populations either experience a crash or simply migrate. With that being said, the upwelling system becomes an unfavorable fishing ground and has a negative impact on the Peruvian economy. It was a pleasure making this video. I hope that you are now more informed about this topic and took some of this information with you. Thank you for watching.